Thank you, Mark. So this is true, as you just have heard. My name is Niklas Roy. I work with electronics, with mechanics, and with code. And I will just show you a few of my projects. And I have to say that I'm moving more and more away from the electronics and the code. And I'm more and more working with hardware store materials. This is why I gave the talk Future from the Hardware Store. But still, all my machines and installations which I build are pretty much inspired by what I know about coding and what I know about electronics. I absolutely love hardware stores, and I'm in the super nice situation that I just have around the corner from my place 2 very large hardware stores. And what I really like about hardware stores is the tremendous potential which is in there. There are all kinds of machines in hardware stores, and I'm not talking about the machines which are already assembled, like a drilling machine or an electric saw. I'm more thinking about the machines which are not built yet, which are just in the hardware store, but which require your imagination and your time to make them. So if you think about plumbing materials in combination with vacuum cleaners, with pulleys and ropes, there is just really a lot of stuff in there which just waits to be made, and it's all already in the hardware store. Hardware stores are, in my opinion, something like toy shops for adults. As you can see on this picture, they also pretty much look the same. And I think it's also this slide here, Mark, now you can turn around. It's this slide here which probably qualifies me to speak at Play&Make. So talking about children, childhood, this is me in my childhood here. I knew nothing at that age about dinosaurs, but I knew everything about the Apollo space program. So it was very clear that I, when I would grow up, would want to become an astronaut. But at the same time, I also wanted to become an artist because I really like drawing. And I also wanted to become an inventor because I had a very influential book for me. It was Der große Augenblick in der Technik, the big moment in technology. And I was totally excited about guys like this one here, Samuel Morse, the inventor of the Morse code. And I really admired Thomas Alva Edison, the inventor of the light bulb, and also Alexander Graham Bell, the inventor of the telephone. But there was also another inventor which was probably even the most influential for me in my childhood, which was, there we have the telephone. I thought now would come another slide. It was this guy here. It's Arthur Fischer. He holds 570 patents. He's from Germany. He's the inventor of the plastic wall plug. But he also invented a children's toy, which is called Fischertechnik. So some people know Fischertechnik still. It was an extremely cool toy. It was a construction set out of those plastic sticks that you could put together, and you could build all kinds of machines with it, which were driven then by motors. And this was really my most beloved toy. I was playing with this all the time, constructing some sort of weird machines. And one morning, I clearly still remember this. It was before in the age when I went to school. I must have been around 5 years old. It was a Sunday morning. My parents were still sleeping. And I was building a machine which was supposed to function with a motor, but it didn't work. So I investigated the whole mechanism thoroughly, and I came up with the conclusion that the batteries were just empty. So I also had this extra set here out of those metal rods. And those metal rods, as you can see, they have those little banana plugs, and you can make some sort of sliding contacts with them. And I thought that those metal rods will solve my energy problem, together with a wall outlet. And you have already in mind what happened then, but I will show it to you. So that woke up my parents very fast that Sunday morning. And I'm telling you this because my methodology is still the same, how I work. It starts with some sort of curiosity. Based on this curiosity, I develop a theory. And then this is followed by an experiment and the experiment, of course, leads to a result, which is that it either works out as I expected, or it doesn't work out. And when something doesn't work out, this is normally the moment where I learn something. So this is actually quite cool. But the coolest thing about this whole procedure is that there is a feedback loop built in, because at every stage of when I'm building something and when I think about it, it raises some questions, and this leads to further curiosity, and then I make again theories and experiments and whatever. So it's like a never-ending loop. Can also forget this whole picture, and we can make it short. What I'm doing is basically I have an idea and I carry it out by myself. I don't delegate it to others. So I'm more into DIY than came yesterday up with the acronym LIMBO, let it make by others. This is not what I like. So I'm really doing the stuff by myself, and I learn a lot by making stuff by myself, and this creates a lot of ideas. And people quite often ask me, where do you get your ideas from? And that's exactly it. It's because I'm just making my own things. So this here is my playground. It's an old shop front in the east of Berlin. Another question that people ask me quite often is, how do you make your money? And well, the easy trick to survive for me is not to pay so much rent, or to keep the running costs very low. So this is not only my playground from inside my workshop, it's also my living room. I'm living there together with my girlfriend Kati, who's also somewhere in the audience. And we are also sometimes making projects together. Towards the end, I will show you some projects which we have done together, and before I show you a few projects which I've done alone. Yeah, we just talked about curiosity. So, of course, there is also some slight curiosity problem with such a large shop window, which has to do with the neighbors. They feel very invited to look always inside. And that can be nice, but it can be also annoying. And a while ago, I decided that I will block the view from my neighbors and hang up a curtain and surprise them with that, because they're so used that they can always look inside. And I knew that I would surprise them with that. So I made a little video about it, and I will show you their reactions. So I want to stick with this project for a very short moment. You have seen in the video this kind of image recognition software which I've programmed for this installation. This is now a screenshot of the very first version. I've programmed this in processing. It's a language that most of you probably have heard of and which makes it extremely easy to read out a video signal and then to interface it with some electronics and to do such a thing. This program then ran on a very old laptop of mine, which I didn't use anymore. And even though this was a very old laptop and not really useful for Adobe whatever stuff anymore, I still think that this was pretty much high-tech. There doesn't really exist a definition for high-tech, but my personal definition of high-tech is that this is technology where there simply doesn't exist one person on this entire planet which completely understands how it works. A computer is nowadays, and even 10 years ago, already so complex that you need a team of people which understand how to construct it, how to make it, and then another team of people which are able to program an operating system. But there is not one single person who can make this from the ground up, such a computer, including software and including this image recognition. And I'm very much interested in understanding the technology I'm surrounded with and which I'm using. So that's the reason why I don't really like this kind of high-tech, even if it's totally outdated. Another project which I have done is Ping. It's a video game console, and it's an augmented reality video game console. And there I also tried to implement some computer vision on much simpler hardware. It's basically hardware that could have been built in the 70s already. And I wanted just to try out how simple can I get with computer vision and with the computer where it runs on, so that I can still understand somehow what am I doing there. The console works like this, that it's some sort of an interface. You take some sort of a video signal, let's say from a video camera, and then you feed the video signal into the console, and then you go out of the console into a video monitor, and what it does is it overlays a pixel, and you will see here in this video how it works. So you can try out this game by yourself if you go to Karlsruhe, to the ZKM. It's the largest media art museum in Germany. And there it's included now in the new permanent exhibition. But if you don't want to go extra to Karlsruhe, you can also go to the internet. On my website, niklasroy.com, if you scroll down at the projects, you will find Ping there. And there I've described entirely how it works and also how you can build your own. So there are all the schematics online and also all the codes. If you open up the console, let's make it here magically on the screen. This is how the console looks from inside. As you can see, there are not really many parts inside there. It's actually, if you buy all those parts, you will stay well below 10 euros. And we can have a quick closer look to what we have there. So the biggest chip on this board is an Atmega 8 microcontroller, which is basically something, I mean, many of you have heard of the Arduino. So at the very first version of the Arduino, this was the main chip. So it is some sort of a little computer that you program on a PC. And in that case, I have written the program in C. And then you transfer it with some sort of a programming adapter on the chip. There it's stored in a flash memory, and then it executes always this program just when you power up the chip. Every computer needs a clock to function, which is a quartz crystal. In that case, it's a 16 megahertz crystal, which runs that computer, in opposite to what you have in a modern laptop, a few gigahertz. So it's a lot slower. Then what we also have here is one other chip. It's a sync separator. This extracts the sync signal out of the video signal and feeds it in the microcontroller. So the microcontroller knows actually where the picture is drawn at the moment. Then there are a bunch of resistors, and those resistors are basically the graphics adapter of the whole construction here. So they are at the end responsible to draw an image on the screen. So, yeah, this here is an assembly of the data sheet of the microcontroller. And I have to say that even though I can read this 300 pages data sheet of the microcontroller, where is exactly described how this chip is supposed to behave and what it can do and what all the different registers do in there, I still have to say that I don't completely understand how it works. Or my understanding, maybe I can understand how it's supposed to behave, but I don't understand it to the extent that I actually could build my own microcontroller. I don't know how to etch this out of a piece of silicone, such a microcontroller. So with the next project, it was a workshop where I've been invited to from the School of the Arts in Offenbach earlier this year. I wanted to explore this a little bit further. How do computers work? I've been there invited from the professor of the new media class, and he asked me if I would have an idea what I could do with the students. And I said, yeah, well, let's build computers out of cardboard. And I had actually no idea how you can build a computer out of cardboard. But I thought that playing with cardboard, this is something that you usually do in the kindergarten. And if you have some sort of a kindergarten skill and bring it to an art school, then the art students will be also able to make something with that kindergarten skill. So what I brought there as an inspiration to the students were 3 books. One was an autobiography of Konrad Zuse, Der Computer, mein Lebenswerk. Konrad Zuse is one of the computer pioneers who has built, he started during the Second World War to build one of the first computers out of telephone relays. I also brought them a book, Personal Computer in- und auswendig. This is from the 80s, and it's a pop-up book which explains how PCs work. It's quite funny. Here is a keyboard. At the end, you have a printer who then prints Auf Wiedersehen, goodbye, when you pull here. It's a matrix printer because of, 80s. And the third book which I brought is a book which I found in the trash in North America on the street. It's called Engineer's Mini Notebook, Digital Logic Circuits. It's from Radio Shack. And it explains how all the logic chips of the 7400 logic family work, if someone of you knows about that. So this is what I brought to the students, but well, I want to step back in time a little bit once more, when there was also this situation that the professor has announced already the workshop to the students while we didn't agree on a deal yet, which put me in quite a good position for negotiations, because I knew that he could not step back from this anymore. And I told him I will only do this workshop if we have 1,000 euros for materials. So we bought a lot of really, really expensive cardboard. It's so-called wood pulp in English, auf Deutsch Finnpappe. Architects like to use this for building models because it's very sturdy. It has a lot of very long wood fibers in there, and you can build really sturdy models out of it. And because we had so really nice material, I asked the students if they would be okay if I would not traditionally teach them something, but if I would just sit there and build my own cardboard computer, because I was really excited to work with this material. And the students were absolutely all right with it. And it also turned out that it created a very nice peer-to-peer learning atmosphere, because we were all just trying out what can we do with this material, and then everyone was looking at each other, and as soon as someone has found out what works, well, all the others were copying it, and by that we were learning very, very fast together. It was a super fun workshop. It was really a nice time. I want to show you 2 students' projects of this. This here is Speedway Pro 1000 from Jonas von Ronström. It's a driving simulator, but there is some sort of a wordplay in there. The Pro 1000 stands for Promille in German. So it's a drunken driving simulator, because it turned out that the steering was actually quite wobbly. We documented all those workshop results in animated GIFs, because this is just a very quick way to document something and you don't have to make a full video. Here is another one. This was from Caroline Liebel and Lisa Hopf. They were totally into this engineer's mini book for digital logic circuits, and they have built a fully functioning NAND gate. A NAND gate is a piece of electronic circuit which every computer has in. It's a very elementary piece of circuit. It's comprised out of a bunch of resistors. And what it basically does, it takes 2 inputs, 2 binary inputs, which can be either 1 or 0, or true or false, and it creates an output out of this. And the NAND gate, which stands for not AND, so it is an inversed AND gate, is a special one amongst all the, all the gates, because it is a universal gate. You can build all other logic gates out of several NAND gates. And then out of all the different logic gates, again, you can build like everything in a computer. You can build memory, you can build the whole processor, and everything what is needed for the processor. So on the left side, we have 2 inputs here. These are those 2 sliders. When you push them in, they represent a 1. And when you push them out or pull them out, then they are 0. And then the output is on the right side, the piece which is shifting out. So basically, when you build like really many of them, and if you have a very, very large room and you lay them out on the floor, you can build a whole computer with that technology. So now I want to show you the outcome of my little project there. I was interested in building a machine which uses digital data, a set of digital data, and puts out some sort of an analog output that you can really touch. And as Mark has mentioned it already, it became a plotter. I took the time when I was back in Berlin to make a little video of it, because I really like to document my own works in videos and put them on my website, because in the internet, I can actually reach a much larger audience than if I would exhibit it in a physical space. And also, I get a lot of knowledge from the internet about the works and how technical things are done. This is why I always like to put stuff back on the internet when they are done. It's like, yeah, it's like I digest the internet and then I put it back somehow. So let's have a look at the video. So the digital memory is here on the left side, this book, as you can see. can see those lines here, which I've drawn on it. It was all cut with a knife, so we didn't use any laser cutters. We were drawing on the cardboard and then cut it with knives. Also, people are asking me constantly about if they could have construction plans of this, but I have to say I'm sorry. There were simply no plans. I just started to work. I just started to work with the little sliding thing for the pen, and it added up and up and up, and it just grew the machine. At the beginning, I didn't know how it would look like at the end. And then I used it to write down the title of Aram's talk. This was pretty much looking in the future. So now we have been at like futuristic technologies built with DIY materials. But let's get even more futuristic, and let's go a little bit more into the hardware store direction. Here we have a bunch of hardware store materials on the floor of this church. This is now a workshop which happened 2 months ago. Kati and me have been invited to give a workshop at the KIK Festival in Namur in Belgium, which is not far from here. And their topic this year was Next Utopia. So they asked us if we would have an idea for that, and we suggested that it would be actually cool if we would transform ourselves into cyborgs. But we also thought that it would be quite interesting if we would make cyborgs out of ourselves which don't really work with electronics, but instead just work with those hardware store materials. So again, I want to show you 2 examples of what the participants have done. This is the project of Jordi and Sam. They thought that it would be quite nice if they wouldn't have to use their MP3 player when they go jogging and want to hear music, but they wanted to use the energy of the jogging itself or of the walking and build a machine which produces then sound based on their movements. Again, we have documented this in animated GIFs, so let's have a look. I put some sound under it here. So you could see there was like a rope going to the back to this backpack, and then there was some rattling and klingity-klang machine inside this funnel. Another project which I really liked was from Martin and Xavier. Martin is a graffiti painter, and he thought that it would be cool to make some sort of a graffiti painting machine which would allow him to tag up the neighborhood in about 4-meter height without taking a ladder with him. So he used these PVC pipes, which are usually used to put in the wall, and then you put electric cables through them. This is very cheap material, very lightweight, and you can build constructions quite easy with them. And then they built this plotter mechanism, which was then controlled by a bicycle brake, and you had a protection over your head out of a plastic bowl, because there was some spray paint always coming down. So this is the device in action here. By pulling on the ropes, he could move the spray can on top. Then he also had a little mirror that he could see what he's painting, but it turned out, obviously, that it's easier just to look up there. And again, for this workshop, Kati and me were so excited already beforehand that we also thought we should build our own cyborg constructions. And we wanted to try out what we can do with those kind of materials. Kati had the idea that it would be really nice if she would have like a rainbow machine, which would create a rainbow around her all the time. And we made that with such a general purpose pressure sprayer, which is probably usually used to poison your apple tree in the garden. And it had a nozzle then, like the pipe was made longer. It had a nozzle on this rainbow head. And as you can see, when it sprays out water and when you're in sunlight, it creates a really nice rainbow around you. And I am not very tall. Sometimes I wish I were a little bit taller. So I have built this head-level extension device for myself, which would elevate my perception by the height of one head, so that I can look on other people's heads down when I wear it. And also I can hear a little bit higher. I didn't want to go so far that I also smell higher, because I like the style of how it was. So this was built out of a construction helmet where I cut a lot off, and then those noise-canceling headphones, which are connected again with those electric hoses to some funnels. So now we are at the future here of well, how we can develop as mankind and what the next level will be. But here we have a nice group picture also. This is all of us together. But I want to go a little bit back in time, and I want to come to the big ideas of mankind, big ideas for inventions which never became true up to now. And I want to talk about perpetual motion machines. Perpetual motion machine, that's an idea which came up for the first time in the 8th century already, not far from here in Bavaria. I didn't find any pictures of that in the internet, but I found on the left side a drawing from Leonardo da Vinci, which is from around 1490, and he has drawn a so-called unbalanced wheel. That's a wheel which is more heavy on one side, so once you start to spin it, it always pushes its weight to one side and becomes more heavy there, and it would theoretically spin on and on and on and on. The same construction you can see on the right side. It's from 1920, a magazine cover. And I thought, these big things of mankind, those big problems, I will tackle them. When I was invited to the Wro Art Center in Wrocław in Poland last year, there I had an artist residency, which basically means that they invited me for 1 month of time, gave me some money for producing something, and I had absolutely freedom of what I could do. So I thought I would build such a perpetual motion machine with their elevator. Here we see a drawing, how it works, but I don't want to get too much into this, because again I have a video which explains it very well. So the trick of making videos is that you can make something make look like it would work perfectly. Unfortunately, it did not work perfect. I mean, it worked perfectly for 2 hours, but after 2 hours, the computer completely broke, and we had to call the service technician. And I was actually feeling really, really bad about this, because I thought I'm causing now a lot of costs for this art center, and they probably don't have so much money anyway. So I asked the technician if I can go to the control room with him. This is the picture which I've taken there. And what you cannot see on this picture is how really hot it was in there. It is an hydraulic elevator. So what happens is that every time when the elevator goes up, there is hydraulic oil pumped in there. And when it goes down, there opens a valve, and the hydraulic oil goes back in a container, in a reservoir, through this little valve, and it really heats up then at this time, the oil. So when we entered that room, it was just really hot. You could have made a sauna in there. So maybe the machine which I've built was actually a control room sauna or so. So in a way, this perpetual motion machine project was some sort of a fail, I would say, as an invention, which puts me back to my childhood dreams, where I wanted to become an astronaut, an artist, and an inventor. And it's quite obvious that, this with the inventor, if I have achieved this, I would put a big question mark there. It's not really clear. I mean, my machines obviously fail, but still, even those failing machines still seem to qualify as art. So I can say that I'm an artist now. This is how I make my money and how I make my living. And I did not become an astronaut, unfortunately not. But I also have to say that I didn't really put much effort in this career path. The only thing that I've done the past 40 years is that I have been brushing my teeth on a regular basis. Because what I know is that the astronauts, at least of the Apollo program, really had to have flawless teeth. So my teeth are in a pretty all right condition right now, which means that this guy here, John Glenn, at the time when this photo has been taken, he was 77 years old. He is the oldest human being who has ever been in space. And 77 years, I still have quite some time to achieve this goal. But now I want to come to the last project in my presentation, and I want to stick with the theme of the artist, of being an artist. I know that there are some art students here which also want to become artists in the future. And I can tell you it's actually super easy to become an artist, and I will show you how it works with this last project. Again, it was an invitation to Poland. I have quite a run in Poland at the moment. The Katowice Street Art Festival invited Kati and me to make an installation there, which was some sort of funny because we really don't have any background in street art. I made once when I was 16 years old, one graffiti, and I looked at it the next morning and it was so shit that I just gave up right away again. But we do have quite an expertise in street-level shop fronts. So we thought it would be quite nice if we would just have such a shop front and pick up people from the street and make instant artists out of them. The Street Art Festival has organized this abandoned shop here. It was empty for more than 10 years, and before it served as a vodka bar. So it was in quite a bad condition, but with a little bit of paint, we made an art gallery out of that. And in that art gallery, in the shop window, we were putting this device here, which is looks like an easel at the first glance, but it's a painting machine which is rope controlled. I have constructed this machine in Google SketchUp, which I really like for constructing those kind of things. And then here we are totally at hardware store materials. Like everything that I needed to build this machine, we found it in the hardware store. So I just made this in SketchUp, and then I printed out the plans, how they look like how they would be on the sheets of wood. I printed that out with the inkjet printer, glued it on the wood, and just took an electric saw and cut it out. There is no like CNC router or so involved in it. It's just basically the tools which I like most to build such a thing is a computer to get information and a printer to get something physical out, a cheap inkjet printer, and then a cordless drill and an electric saw. This is like my Fab Lab at home. And Again, the plans for this are on my website, so have a look there if you want. And you can build one your own. I don't really believe in copyright. I believe in that you can just use my stuff and make whatever you want with it. And yeah, the aim was to create those professional art careers. So we did not just want the people to make artworks in the shop window. We really wanted them to become professional artists, which means they had to make money with their artist painting as well. And again, I made a video, and I will leave you with this video. This will be the end of my talk. Enjoy it.
Zloty, 55 zloty, 60 zloty, 65 zloty,